Bismillahirrahmanirrahim. This lecture is about solids. So in this lecture, we will discuss about the kinds of solid, crystalline solids and their characteristics, X-ray crystallography, and Bragg's equation. So let's first move to the what is happening when there is the phase changes from solid to gas or from solid to liquid. So there is one possibility when there is the sublimation process when solid is directly converted into gas. And these are very important parameters. That means the change in enthalpy must be greater than zero. That means it is having the value of plus. And when value of delta H is positive, it is called the endothermic reaction. So sublimation process is actually the endothermic reaction. So when there is a sublimation of the solid to the gas, there is the increase in change in entropy because the solid molecules or the atoms are perfectly ordered or having the less disorderness as compared to the gas, and gas molecules are present in a highly disordered form. So there is the increase in change in entropy in a sublimation process. So that's why the both having the value greater than zero, that means having the value of plus, and in this case is also positive. So there may be a reverse process when the gas is converted into the directly into the solid. This process is called the deposition process, and for this one, energy must be released for the conversion from gases to the solids, and that's why this process having the change in enthalpy less than zero. That means the value of delta H will be in minus, and if it is minus, it is called the exothermic reaction. So energy is released in this process. And of course, there is the decrease in change in entropy because the molecules are converted from the highly disordered to the ordered form, from the gaseous to the solid form. So there is one conversion. Another one, solid may be converted into the liquid, or maybe the liquid is converted into the solid. If it is solid is converted into the liquid, that means the phase change from solid to liquid. Then this process is called the melting, or simply you can fusion process. And for this one, conversion from solid to liquid, should be the increase in change in entropy, and the process will be the endothermic reaction because energy is required for the conversion from solid to the liquid. In the similar case as we have discussed in the sublimation process. So in the freezing of the liquid to solid, energy must be released. That's why this will be the exothermic reaction. The value of delta H will be minus, and the value of change in entropy in case of conversion from the liquid to solid or in the freezing process will be less than zero. That means the change in entropy will be less than zero. Entropy is going to decrease from the conversion from liquid to the solid. So this is, we are going to discuss about these solids. So there are the two fundamental distinction between the kinds of solid. One is called the crystalline solid, another one is called the amorphous solid. So how can you differentiate between these two solids? Crystalline solids, that mean where the atoms, ions, or the molecules have a ordered arrangement extended over a long range as shown in the example 1. So that means if the atoms or molecules are present in a more ordered form, then this type of solid is called the crystalline solid. Like it is an example of the sodium chloride crystal over here. So by contrast, if there is the molecules are randomly arranged, that means not in the order form, then the solid will be called a amorphous solid. And rubber is an example of the amorphous solid. So here it is a general overview of the types of solids and their general characteristics. So I'm going to differentiate. That means there are four different types of the crystalline solids: ionic solid, molecular solid, covalent network, or the metallic network. So you can differentiate based on the intermolecular forces, and you can also differentiate based on the properties, and here are some of the examples. So let's move ionic solid. So ionic solid, very simple as it is very clear from the name. It is the ionic solid. That means if there are the intermolecular forces are ion forces, then the solid will be called the ionic solid. And where there are the ion forces, where is the ionic bond formation between the cation and the anion. So because the ionic bond is formed with the transfer of electrons. So ions are present, like in this case, sodium chloride, the electron is transferred from sodium to the chloride. So it becomes a positive, and chlorine become a negative charge. So there is an attraction between the positive and the negative. So actually the interaction between the positive and the negative, or the ion charge, are called the intermolecular forces, are called the ion forces, and in which these forces are present, the solid will be called a ionic solid. So what is the molecular solid? Again, based on their intermolecular forces, if weak forces are present between the molecules, and these weak forces are dispersion forces, dipole-dipole forces, or the hydrogen bond, and then the molecule will be called the molecular solids. So here these are the example. Let's suppose in case of the water, the hydrogen bonds are present between the molecules. So we are talking about the intermolecular forces. That means how one molecule of the water is going to be interacted with another molecule of the water. So basically hydrogen bonds are present when hydrogen is bonded with the oxygen, nitrogen, and fluorine mainly. So here the hydrogen is bonded with the oxygen, much more electron activity difference is there, and hydrogen is present in between the molecule. That's why the forces are called the hydrogen bonds or hydrogen forces. So in case of the bromine, and this is the non-polar molecule, and in all these there is the covalent bonds are present. So we are talking about the intermolecular forces. That means how one bromine molecule is going to interact with another bromine molecules. So because this is a non-polar molecules, and there should be a weak forces, and we call it the dispersion forces, or another name of the dispersion forces is the instantaneous induced dipole forces. So similar forces exist in CH4 molecule, and this is carbon dioxide. Here the two poles are present, partially negative. Oxygen is a partially negative, carbon is a partially positive. So two poles are present in a molecule, and the attraction between the carbon dioxide molecule will be the dipole-dipole forces. So if these type of forces are present, and these are the examples, then the solid will be called the molecular solid, and their property, these will be the soft, low melting point, and non-conducting in nature particularly. So moving to the third type of the solid, it is called the covalent network, and as you know, it is the difference between the molecular and the covalent network, because these are the giant molecule, like in case of the diamond or the graphite or the silicon oxide. So the atoms in a whole of this network are bonded with the covalent bonds, and they are present in the network. That's why they are called the covalent network. they are very hard and high, having the high melting points or the boiling point. The first and last example is the metallic solids, and simply if the intermolecular forces or the bond between the metals are present at the metallic bonds, and due to these intermolecular forces, the solid will be called a metallic solid. And the example are like sodium, zinc, copper, iron. There are many other examples of the metals in which metallic bonds are present, and the solid will be called the metallic solid. And they have the variable hardness and the melting points, and they are conducting in nature because due to the unpaired electron present in the d shells orbitals. So moving to the next topic, which is the X-ray crystallography and the Bragg equation. Actually, we will discuss very briefly here, and because this is the long topic having a lot of the content should be covered, but we will be very briefly discussing about the X-ray crystallography and the Bragg equation. So what is the first is the X-ray. X-ray is one type of the electromagnetic radiation, like it is the gamma rays, UV, visible, IR, microwaves, radio waves, and X-ray is also one of the electromagnetic radiation. But importantly, it is having the wavelength of 10 exponent minus 10 meter. If it is the wavelength of the wave is in this region, then it is called the X-ray. So what is the diffraction? Actually, this is the source of the X-ray coming from the X-ray tubes and going through the lead screen, and when it falls on the crystal, the X-rays are the diffracted. That's why this is called the X-ray diffraction. So by using this data, we can actually determine the crystal structures of the solid. So this is the importance of the X-ray crystallography. So for the X-ray crystallography, or there are two main interferences of the wave. One is called the constructive and one is called the destructive interferences. So let's first differentiate between the constructive and the destructive interferences. Constructive interferences mean like that's what this is the one wave, and this is called the of course this is the crest, this, and the lower portion will be the trough, and both waves are in a phase. That means if you sum up these one, the intensity is going to increase. So this type of the interference is called the constructive interference, because the summation will give you the more intense wave as compared to the individual waves. So what is the destructive interference? If you look at this wave, this is the crest and this is the trough. That means crest and trough both are opposite to each other. So one of the trough and one of the crest is summing up with the trough of another wave. So when you sum up these one, actually these are the out of the phase and they cancel out the effect of each other and you will get nothing here. That means it is the straight line. And this interference is called the destructive interference. So for the X-ray crystallography, constructive interference is the must for the X-ray crystallography. So that's why we have discussed over here. So let's move to the Bragg equation and what actually we are getting out of the Bragg equation. So let's move first. There is a small derivation. So this is the first layer of the atoms of the any solid, and this is the second layers of atom. Let's suppose this is the sodium chloride crystal. So first layer of the atom, second layer of the atoms, and this is the incident light. Incident light means X-rays. So when X-ray light, and this is the wavelength of the X-rays. So this is going to fall on the atoms present on the X-rays, and then the light is diffracted. So let's suppose there is another X-rays which is going to fall on the second layer of the atoms. So again, this is the X-rays going to fall the second layer of the atoms, and then this is diffracted after interaction with the atoms present in the second layers. So again, now we are going to apply the constructive interference over here. So look at the both waves. This is the crest. This is also crest. This is the trough. This is the trough. That means both waves are in a phase. That means there is the constructive interference between the waves, and both the incident waves and the reflected or the diffracted waves. So this is the first requirement for the X-ray crystallography. That means there should be the constructive interference before the falling of X-rays on the atoms, and after the diffraction, the both in there should be a constructive interference between the waves. So let's now move to the derivation. So this is the X-rays falling on the atom. Let's suppose this is the point A, and the distance between these two layers, it is called the D. It is the point A, and let's suppose this atom of the second layer, this is point C, and the distance between A to C, it is called the D. So this is very important. Actually, by using this Bragg equation, you can calculate the distance between the two layers, and this we are going to calculate over here. So what is now, I am just by using the constructive interference, this is the total waves over here, and let's suppose I am drawing a line from point A to here, point B, and point A to here, point B dash. So after connecting B dash to C or B to B dash, look, this is a type of the triangle, and this is also a small triangle, and both triangle are same or equal, similar to each other because there is a constructive interference. So I'm going to solve the first triangle, and this is the theta. Theta is the incident theta. You can say the incident theta mean because this is the incident rays, and there is the first ray, the first layer of the atoms, and the angle between the ray and the first layer of the atom is the angle of the incident, and this you can say this is the theta of the diffracted rays. Or so this is the, actually I want to calculate what is the angle of this triangle. So this is simply, if you have a simple look over here, this is a triangle. I'm just using the trigonometry and want to calculate the sine theta. And sine theta is, here is the theta, sine theta is, that means A divided by the CZ, that is opposite to the ratio of the sine theta, that is the A over C. So I am using this triangle to calculate the sine theta. So sine theta over here is, the angle of this one will be equal to BC divided by D. So this is the ratio between BC and D, that is called the sine theta. I am using this trigonometry to solve the to calculate the D spacing, that means the distance between the two layers. So it is very simple. If you want to calculate the BC actually is the extra distance traveled by the second rays and the incident rays, and this is the extra distance traveled by the diffracted or the reflected rays after colliding with atoms present in the second layers. So that means this is the extra distance, this will be the extra distance, incident distance, diffracted distance. After this, the both again rays are in a constructive interference. So this extra distance I am going to calculate. So what is the extra distance? This extra distance will be equal to, you have to multiply D with the sine theta. So BC will be equal to D sine theta. So I have calculated this extra distance, and now because these two triangles are the same, because there is a constructive interference. So similarly, CB dash will be also equal to the d sine theta. So the sum of the BC sine theta plus CB dash sine theta, that means sum of this and sum of this will be equal to 2d sine theta. That means d sine theta plus d sine theta. So it will be the 2d sine theta. So let's move to the another assumption. So when these two are going to be summed up, that means in case of the constructive interference, their summation will be 2d sine theta is only when this whole number will be equal to n lambda. That means if the wavelength is any integral number, that means 1, 2, 3, 4. So maybe 1 mean 1 lambda, 2 lambda, 3 lambda, 4 lambda, and lambda is the wavelength. So they only be summed up when there is 1 lambda, or there is a 2 lambda, or is the 3 lambda. If it is in the fraction, then there should not be the constructive interference, and you cannot apply this trigonometry to calculate the d-spacing. So for the constructive interference, if you sum up this one, and it is only be happened when it will be equal to n lambda. So BC plus CB dash will be equal to n lambda. So that means this we have already derived over here. BC plus CB dash will be equal to 2d sine theta, and this I have explained that BC plus CB dash will be equal to n lambda. So that means 2d sine theta will be equal to n lambda. So d you can calculate from this equation, and these are going to be divided by the n lambda. So this is the simple formula. D is the, again, this is the d spacing, we call the d spacing, or spacing mean the distance between the two layers, between the first layer and the second layer. So you can calculate the distance between the two layers by using this equation, and this equation is called the Bragg equation. So n is an integral, lambda is the wavelength of the X-rays. 2 is constant, sine is the trigonometric parameter, theta is the distance as we have solved over here. So if you know the theta, you just put the theta and put the value of the lambda or wavelength of the X-rays. You can easily calculate the Bragg. You can easily calculate the d-spacing or the distance between the two layers by using the Bragg equation. So this is all about our lecture on the solids, their type, crystallography, and Bragg equation. By using Bragg equation, you can calculate the d-spacing. Thank you for watching.